This video is for Unit 10 exam review for circles. We will be covering the first page problems, which include quick questions where we are given a problem scenario and we are to match up the equation that we would use to solve the problem. We're not actually going to solve, we're just going to choose the correct setup to help us. So, question number 1. Identify the formula for the given scenario. We are looking at an arc measure of 125 degrees. And in each of the formulas, we're asked to find angle DAC. So angle DAC would be a central angle, angle DAC. And the question is, how is angle DAC related to this arc measure? Well, we know that a central angle is actually equal to an arc measure, so our choice is going to be the first option. It's not half, it's not 2 times, it's not 3 times. The central angle is equal to the arc, and we get our first option. Number 2, if we look for our answer choice, we look for what we're trying to find. We're trying to find BC, arc BC. That's this measure right here. Well, how is arc BC related to our given angle measure of 75? Now the 75 we can see is an inscribed angle, and we know that every inscribed angle is related to the arc, that the inscribed angle is half of the arc, or conversely that the arc is equal to 2 times the inscribed angle. So looking again, the arc would be twice as many as 75, so we're going to again choose our first option here. Going back to that very basic example that we gave when we first learned about inscribed angles, if I draw an inscribed angle here and I told you this was 25, you would tell me that this is 50. That relationship happening, that if I told you this was 50, you would take half of that for the inscribed angle. Okay? So in this particular case, the arc is equal to 2 times the 75 degrees. If this were the reverse, if I was looking for the angle, we would take the arc divided by 2 or times a half to find the angle measure, but that's not the case. Number 3, we are looking for the angle measure TVU. TVU. Now once again, we see that this angle measure is on the circle, very much like number 2, where we had an inscribed angle where the angle measure was on the circle. So we have that relationship happening that the angle is equal to half of the arc, or the arc is 2 times the angle measure. Well, the angle measure is half of the arc, so that means that the angle measure is equal to half of our arc of 120 degrees. Number 4, we see a scenario where we have our angle measure is outside of the circle. So our angle measure in question is outside of the circle. So we can immediately eliminate the first 2 options because we know our formula relates to half, very similar to all the formulas we've had so far, but it involves taking these 2 angle measures these 2 arcs that we intercept, this 90-degree arc and this 190-degree arc. Well, how is this angle measure related to these 2 arcs? Well, since we are outside the circle, we are in fact going to subtract the 2 angle measures, the bigger arc minus the smaller arc, 190 minus 90. Taking half of that gives me angle CBA. If we were inside the circle, we would add the 2 arcs together and take half, but since we are outside, we would subtract. That actually leads us into question number 5, where we are trying to find arc SR, but the known given angle that we see here is actually 117 degrees, and this angle is inside of my circle. So once again, we can eliminate the first 2 options. The first option being a central angle. If this was a central, this would be if we were on the circle. So we have an option of, do I add these 2 arcs together, my unknown arc, which is bigger, and my 79, or do I subtract my 2 arcs? Well, if we are inside the circle, we are going to add our 2 arcs together. If we're outside the circle, we subtract. So since my angle measure was inside, we're going to add these 2 arcs together and take half of it. Since I already know the angle, we would substitute in for the angle measure, 117, and then we can go ahead and solve to find the missing arc. Question number 6. Notice here we're not actually trying to find an arc length or an angle measure. We're actually trying to find the length of BE. which in this case is a segment. So this is one of our newer problems when we're trying to find a segment. If we notice, though, this angle measure that I'm given, even though we're not dealing with an angle problem, is outside the circle. Since we are outside of the circle, we had a formula that we were talking about to help us figure out the segment lengths and how it relates to this angle outside the circle. And that formula is the outside segment times the whole segment length is equal to the outside segment times the whole segment length. So what does that actually mean? Well, when I look on my angle, this outside segment of 10 times the whole segment length of 10 plus 17 should be equal to this outside segment length times the whole segment length here. Well, let's go ahead and take a look at our different formulas. We see that these last two deal with, this looks like we're trying to find an angle measure from the previous one, so I'm actually going to cross off the last two because those deal with, look like our angle formulas. So the question is, which of these formulas does this outside times whole equals outside times whole? Well, outsides are 10 and 10, 9 and 9, that looks good. But the whole pieces, this whole piece is going to be 10 plus 17. So not just a 17, but 10 plus 17, which we see here is actually 27. And then here, this whole piece isn't just 9, it's 9 and this x value, or 9 plus x, or 9 plus b. So my answer here is going to be number 6. Okay, please don't get distracted by these angle formulas. It's outside times whole equals outside times whole. We see that happening, this whole same scenario happening again in number 7. We should see outside times whole equals outside times whole. Here we note that we have some subtracting going on in these two middle formulas. There was no subtracting going on. We want to find the whole distance, so we would be adding segments together. So that is out, and so is that. Then looking at this, if I'm looking for outside times whole equals outside times whole, quick note on this, this should actually say CD. This should say CD. Regardless, 18 times 18 plus CD, so that's this whole distance. We have this scenario here where it looks like I only actually have an outside piece, so we may be tempted to choose option number 1. However, the formula says outside times whole equals outside times whole, so I must have multiply two numbers together. In this particular case, this outside piece is also going to double up as our whole piece as well, so number 7 is going to be option number 4, where we're taking 24 times itself. 24 outside and whole is the same. Number 8, we are inside the circle once again. We should see that our angle measures here are inside the circle, but we're not actually finding angles here. We're actually finding a segment length of AC. So what did we do to set this up? Well, we had talked about how this actually really looks like a proportion. If I simply just put a fraction bar equals a fraction bar and then kind of set up my proportion from there, we would actually have 27 over x equals 24 over 16. Now if you notice, none of these are actually this particular scenario, so let's go one step further. I would actually cross multiply here, which would give me 27 times 16 is equal to x times 24. I'm going to write in, instead of x, I'm actually going to write in AC equals AC times 24. And we should see that option 2 is the only one that actually matches up with what we had listed right there. Option 3 and 4 again are trying to find an angle measure. That's the particular formula we were using earlier. Here, this is the only way that it would work out. So it may show up as a proportion, or just maybe after we cross multiply. Number 9 is, once again, we're looking for an arc length. Arc length, which is from a given angle measure outside of our circle. So we're looking for the angle measure of 43 degrees. That's the angle measure. So these two are out. So if I wanted to, how is this angle measure related to these two arcs? Well, we're not going to add them together. We're going to subtract. And notice here we are subtracting in both. But how do I actually go about subtracting this? Well, we subtract the bigger arc minus the smaller arc, which in this case the bigger arc is 145 and the smaller arc is QS. So we would choose option number 1. Lastly, number 10, we are once again looking to find an angle measure inside of my circle. So the way that I do this is, how is this arc and this arc related to the angle measure in question, well, I would simply, the angle that I'm looking for is equal to the sum of the two arcs divided by 2. So that means I'm going to choose option 3. We are the angle measure is unknown, so that's why these two are out. And we're not subtracting, we're actually adding. Be ready for some quick questions for the test. The first 10 questions are all going to be quick questions. A few circle questions, which we'll get to here towards the end, but these diagrams are the majority of them.